We're going to look at differentiating each one of these examples using the process multiply the coefficient by the power, decrease the power by 1. So looking at the solutions for these questions. Question 1, the result of differentiating this expression gives us dy by dx, which remember is an expression, is notation to demonstrate we're finding the gradient of the curve, defined by y equals 10x to the power 4 plus 5x to the power 6. So multiply the coefficient 4 by 4, so I get 10 times 4, which is 40, x, decrease the power by 1, cubed. Let's make that a little clearer. Plus, coefficient 5 times the power 6 is 30, x, decrease the power by 1, 6 decreased by 1, gives us x to the power 5. It's as straightforward as that. So question 2, result of differentiating is a gradient, which we represent by dy by dx, times the coefficient 6 by the power 5, so again I get 30 here, x, decrease the power by 1, 5 decreases to give us 4, minus coefficient 2 times the power 10, which is 20, x, decrease the power by 1, 10 decreases to 9. Okay, question 3. When we differentiate y equals 8x to the power of 1, we can consider this as 8x to the power of 1 plus 7, and we can consider this as 7x to the power of 0. So what happens here when I actually do this, in terms of officially with the differentiation process, I get 1 times 8, which is 8, x to the power of 0, and then plus 0 times 7, which is 0, x to the power of minus 1. Now that's following it blindly. I'm going to put that in square brackets because we'd never actually do that, because we'd step straight to this answer in a moment. But it's worth pointing out that this x to the power of 0 term here, that's equal to 1. So actually what we get as an answer is dy by dx equals 8 times 1, which is just 8, and then 0 times anything, which is 0, so I just get a gradient of 8. Let's just go back to y equals 8x plus 7. I'll note it at the top here, y equals 8x plus 7. Well, we know from working with linear functions that the gradient of a line of the form y equals mx plus c is m. So in this case 8. The gradient of y equals 8x plus 7 is 8. Now thinking about the constant, if I do the constant y equals 8x minus 5, the gradient of this is also 8 because I'm just looking at this coefficient of x. Gradient of y equals 8x plus 3. The gradient is still 8. This constant doesn't have any effect on the gradient. So in effect what we do is we just drop it. And actually when we come to differentiating linear terms, all we really do is drop the x because all we're interested in is that coefficient. However, here, what I did here in the brackets, you don't need to do this, but it just shows you actually the differentiation process does work with this. However, we can streamline it to do what I did here and just step straight to an answer. Now we'll see this in the examples I'm going to differentiate now. So dy by dx equals 7 times 3 is 21. X, decrease the power, which is 3, by 1 to x squared. Differentiate 5x, I just drop the x, so I get 5. Differentiate the constant, it just disappears. And so it's far simpler than what I had to do in these brackets here. I just wanted to actually emphasize that the process of differentiation still works. However, we can take these shortcuts. Finally, number 5, again the result dy by dx, our gradient, equals 9 times 2, which is 18. X, decrease the power of 2, and it comes down to 1. Don't need to bother writing the 1. So then differentiating minus 4x, again I just drop the x, so I get minus 4. Differentiating the constant just goes to 0. So we get our answer is just simply dy by dx equals 18x minus 4. Okay, that's the differentiation.